My name is Parisa Schulte, and I will be your host today. I'm an education technology consultant for Texas Instruments, and I'm excited for you guys to see what we have to share with you today from our presenters, Tom Reardon and Lee Casera. Tom, do you want to go to the next screen? That's me. I'm not showing video just to save bandwidth today, so I apologize. Go ahead and go to the next one, Tom. These are our two presenters, Lee Casera from UC Irvine and Tom Reardon from Youngstown, Ohio, Youngstown State, Ohio, I apologize. They're going to share with you how TI technology can help students in your college math courses. Do you want to go ahead and go to the next one, Tom? If you have any questions, go ahead and put them in the chat there. You can chat to everyone. You can chat to me as the host separately, or you can chat to the panelists separately. But please feel free to collaborate, add comments or questions there, and we'll go ahead and check in periodically. Go ahead, Tom. I think we're okay there on audio. Okay, so here's our agenda for today. We'd like to basically see how university and community college instructors have been using TI technology in their classrooms, help you get some great creative ideas for how you can incorporate either the TI-84 or TI-Nspire platform into your courses to really help students use graphing technology to conceptually understand and retain the math that they're learning from you. And also see how the TI-84 SmartView emulator or the TI-Nspire teacher software can be used as a powerful demonstration tool for your teaching. At the end of this webinar for attending, we will give you software for both. We'll give you perpetual licenses for both platforms. So that will be emailed to you in the next couple days. And then we'll also share with you how you can get software for the rest of your department and also redeem technology reward points for technology if you would like to. Go ahead, Tom. So these are the expected outcomes of today. Tom, do you want to take it over from here?
Sure.
Okay, great.
So thank you, Parisa, and welcome everybody. So expected outcomes, we hope that you can see the value using graphing technologies to help the students in their learning and their comprehension. Find several ready-to-use activities or share with students to assist in their conceptual understanding again. Begin to use the emulator, either the 84 or the Nspire, that you're getting both of those for free, which is amazing. And locate how to get additional information. And I have a website that I will share at the very end, explaining how you can get all this, including the slides from both me and Lee. You'll get our slides of what we're using. And understand the similarities and differences between these calculators. So with that, of course, don't you know, I'll get phone call on my landline. I'm not answering it. Okay, so these, I thought we'd start off with, these are the instructors and professors from community colleges and universities that have been using TI-Nspire or TI-84 in their affiliations. So this is half of them that we have that we would share with you today, kind of get an idea from that. And then here's the other half of those people there. So just to give you an idea that these are being used throughout the country and have been for a very long time. And I think with that, I will start off and let me change to there we go. So all the materials from today's and last week's webinar, and I see there's some people here from last week, and I appreciate you coming back. This will be different. It'll bit.ly/university, then capital TI. It is case sensitive, okay? So we'll show that again a couple of times, but you might want to jot that down. All the materials will be available at that website. So there are actually 4 different calculators we're talking about, 2 platforms, as Parisa said, but 4 calculators. There's the TI-84 grayscale that's been around for like 20 years. the TI-84 CE color, which is what I'll be using most of the time. They also have a TI-Nspire and a TI-Nspire CAS. Okay, and those are different. I'll explain that difference kind of shortly. Okay, but I first want to talk about how I use the graphing calculator, and I think Lee and other people use it. It's a teaching tool, but also a learning tool. Discovery tool to have the students discover the mathematics by looking for patterns, discover formulas, check answers. I love to use it to check answers instead of the back of the book syndrome. Visualize graph, very big on being able to visualize graph and think graphically. Visualize solving equations by seeing how many solutions there are when you see the graphs. And today, this is really more what I do in calculus, is solve tougher application problems that are impossible to solve, quote, by hand, or they're kind of nasty equations that don't have nice solutions, as the real world does, and so we can use technology to help us with that. And then as a tool to review concepts like electronic flashcards. So I'm going to be illustrating these calculators in the calculus sequence and in linear algebra, matrices, and then Lee will discuss the statistics. But first, let me talk a little bit about the difference between the TI-Nspire CX, handheld, and the CAS and non-CAS. About 90% of the Nspires sold are non-CAS. Okay, so you're not going to hit a CAS calculator, a computer algebra system calculator, very often, but I do want you to be aware of them so that if your students say, can I use my CAS Nspire? And you say, yeah, you are probably going to have to assess a little bit differently, okay? So on the left here is the non-CAS or numeric. Under algebra, there are 3 tools there, okay? But under the CAS, you can see it'll solve, factor, expand, complete the square, solve systems, do trigonometry, all that sort of things, because it does it symbolically, not numerically. And in calculus, which is what kind of where I'm focusing at first, these are the numerical things that we'll do on a non-CAS or numeric. But on the CAS, computer algebra system version, it will actually take the derivative symbolically, do the antiderivative, limits, summation, series, implicit differentiation, does all of that, okay? So be aware. Here's some examples of CAS only, and again, if I'm going too quickly, and I know I am, you do have access to these slides, and you can go back and see them there as PDFs. So like notice it'll solve equations exactly, whether it be irrational solutions, complex solutions, expand binomials, trinomials, factor expressions, even over the complex, complete the square, solve linear systems with nasty answers or nice answers, solve linear quadratic systems, add fractions, do trigonometry. But more for us, you'll notice it does summation. And notice how I from 1 to n of I squared, it actually gives you the formula, okay? Limits on either side, okay? Derivatives, derivatives with respect to other variables, okay? Evaluate derivatives, second derivative, antiderivative, definite integrals, implicit, differential equation solver, Taylor series. I mean, all of that is in CAS. And we're not pushing CAS by any means. I just want to make sure you be aware of that. Almost all the things I will be talking about will be non-CAS. I will specify when it's CAS Nspire, okay? The 84, if you're using the grayscale or the color, does not have CAS. That's the TI-89 that used to do that. So again, I would say most of the calculators you run into are going to be 84s, probably 75% of them, if not more. Of the Nspires you see, almost all of them will be non-CAS, okay? So just thought I'd make you aware of that. So let's go ahead and get started here. Teaching for conceptual understanding. That's kind of a big deal to me. And so let's go ahead and look at calculating this limit right here. The limit as x approaches 3 here. And I'd like students to be able to see this in a table and in a graph first. So let me go ahead and look at this one. So I'll go ahead and clear what's in y equals, and let me make this a little bit easier, a little bit bigger so you can see this better. There we go. And so I'm going to go ahead and put this expression into my y equals. And again, this is not a training. This is more to show you ideas and what's possibilities. Okay, so x squared minus x minus 6 all over x minus 3. And I would want to know what's the limit as x approaches 3 for this, okay? So what I'm going to do is I'm going to do it by table at first. So I'm going to set my table, and it doesn't matter what these table settings are, but I'm going to go to what's called ask mode and independent ask mode. And that means when I go to the table, I'm going to ask for the numbers for the calculator to put in. Since I'm approaching 3, I'm going to start off with maybe 2.9. And you can see it's giving me fractions, and I would prefer decimals. So what I'm going to do is I'm going to go back, and if I put a decimal point anywhere in my expression, it will give it to me as a decimal. So now when I go back to table, 2.9 is now as a decimal, 2.99. I'm getting closer to 3, 2.999, and so on. And as you can see, as I'm getting closer to 3 from the left side, or smaller, this is getting really close to 5. So let me try 3.1, 3.01, 3 and 1,000th, and so on. And you can see that as x approaches 3 from either side, y is getting really, really close to 5. In fact, if I try to substitute 3 for x, notice I get an error because it is undefined there, okay? So the value doesn't exist there at 3, but the limit does, okay? And so I would want my students to be able to see that conceptually. I'd like them also to be able to see it graphically. So if I would go ahead and graph this function, some of the students will say, oh, it's a line. Well, it is, but if I trace, again, as x approaches, let's say 2.9 and 2.99 and so on, okay? But when I get to 3, watch what happens again. It's undefined there at 3, okay? And again, I can approach from left and from right, okay, in this case. Now, I also have this the 84 table, I have the graph. These are all parts of what are on mine already for you. If I did this on Nspire, and Nspire would be very similar to this, so I'm not going to reproduce that one. But I am going to show you what it looks like with a CAS solution. So if you do have a TI-Nspire CAS, computer algebra system version, you define the function, and I let a be 3. And let's say I wanted to evaluate the limit as x approaches 3 of the difference quotient here. I type in that limit of the difference quotient. A has been defined, f of x been defined, and it does all the calculations for you, which is not a fan of that because that's not doing the algebra that I would like them to be able to see, but I want you to be aware of what the power of what it will do. Okay. All right, another one, calculated limit conceptually. Again, here, we're going to look at as x increases without bound. And so let me go ahead and load the state that I have for that, so I don't have to do this whole bunch of stuff because I already have it typed in. Okay, and that's one nice thing about the TI-84 emulator software, SmartView software. You can have different states and have things already pre-done. So you notice I already have this typed in. And now what I'd like to do is look at this again, set my table. Only this time what I'd like to do is I would like the table to have numbers that are very, very large and see what happens. So again, I'll go down to the ask mode. And I'm going to say, oh, let me try 1,000. And you can see what Y1 is approximately. By the way, it has more significant digits, as you can see there. Okay. And then maybe 10,000. And maybe 100,000. Now it looks like it's 0.75, but it really isn't. It's just getting very, very close to that, okay? And so I can, now the students intuitively can see as x gets really, really large, this gets really close to 0.75, okay? And if you also want to get kind of clever, you can actually go off to the home screen and type 0.75 and then convert that to its equivalent fraction in case your students aren't really good at that, which I would hope they would be, but you never know. And you can see this goes to 3/4, and you can start talking about why algebraically, how you can show that that limit goes to 3/4, okay? But you see it conceptually first. So again, by table, I also did this by graph. If I graph this and have X maybe go up to 1,000, you can see that this graph is really flattening out, okay, asymptotic, if you will. And we can see that as X approaches a larger and larger number, Y is getting really close to 0.75, but always below it, okay? So we have a horizontal asymptote at Y equals 3/4. The Nspire solution would be very similar. If I did it with Nspire CAS, I can actually type in the limit as X approaches infinity, increases without bound of that expression, and it gives me an exact 3/4. It does calculate limits. So there is this Nspire CAS in your classroom. Be aware of that. Let me just stop there for a minute and see if there are any questions or comments that have popped up that I should know about. Okay, I'm guessing not. All right, slope of a tangent line at a point. Okay, so let me go back again to this, and I'll clear that. And let me go with y equals x squared, a simple one, though you can get really complicated with these. And I'll graph that, y equals x squared. And what I can do is I can actually say, using second trace, which is the calculate menu, I can go ahead and find the derivative, dy dx, and it'll ask me for what value. So I'm just going to type in at x equals 1, and I can see that the derivative's value at x equals 1 is 2. I can also go ahead and ask it to draw this tangent line at that point by going second program, which is the draw menu, and the number 5 is draw the tangent. And again, I want to draw it at 1, so I'll enter 1. And not only does it draw, it also gives me the equation of that tangent line. So again, being able to visualize things, have them do by hand, and then check with a graphing utility. Nspire will do the same thing as well. In fact, Nspire will also, I did use Nspire CAS here to actually take, no, this actually was Nspire without the CAS. It'll show me taking the derivative at x equals 1. And again, the directions are here. So if you have that, go back and get these slides, and you can walk yourself right through these. Derivative of point for y equals x cubed, I'll just illustrate this one also. If I go to nderiv, in fact, actually, let me show you that. Okay, I forgot that I didn't show you that. So let me go back and do that. So on the 84, I'll go off to the home screen and clear it. Under math, number 8 is nderiv, okay? Also, it's under alpha window. Also has nderive, okay? And notice it's the Leibniz notation. So it says find the derivative with respect to x of x cubed. And then at x equals, in this case, 4. So it's going to take the derivative and evaluate x equals 4. It does not do it symbolically. It's doing it like using Newton's method or something like that. And you'll notice my answer isn't exactly 48 because it is doing some kind of an algorithm, okay? So we do have to talk about that. It is exactly 48. And again, that this is a good approximation, but not exact. Okay, Nspire has a similar way of doing this. Here is the Nspire CAS one, where you actually say, I want to take a derivative, add x equals 4, and it does it for you. Okay, this is using the CAS solution. Any questions or comments? Riza, anything going on? Okay, I'm going to say
Tom,
no.
I haven't seen anything yet. Does anybody have any questions that they'd like to ask Tom at this point?
Well, if you do, just type them in the chat, and Parisa will definitely ask me, okay? Another derivative at a point, they can get a little more complicated, okay? Again, take the derivative, evaluate at x equals 2. This would be one that, you know, is not done it by hand easily, but should be able to be done, okay? And then here's even nth derivatives, okay? And I'm just going to illustrate on the TI-Nspire. Again, this is the TI-Nspire non-CAS, numerical derivative at a point. Type in the variable, what you're evaluating it at, and to choose which derivative, in this case, the second derivative. It has a nice Leibniz notation again. On awful one, this would not be one it would be nice to do by hand, that's for sure, okay? But just making sure you're aware of the power that's there. Finding area under a curve, okay? That is bounded by the x-axis. So let's go ahead and look at that first on the 84 there. So the curve, let's see what the equation is again. I think I want to do y equals the square root of x plus 1. I think I typed that wrong. So let me do that. So y equals the square root of x plus 1, just to make it a little bit different. So second square root of x, get out of there, plus 1. And let me graph that. And I'd like to find the area bounded by the curve in the x-axis from 0 to 4. So that would be under second trace. And number 7 is the integral, okay, which is defines one of the things of the integral is to find the area under curve. So I'll choose that. And it's asking for the lower limit. So I'm going to type in the lower limit, 0, enter. It's asking for the upper limit. I'll type in 4 for the upper limit, enter. And it colors it in very nicely, and it gives me the approximation to it as a decimal, okay, to find the area under the curve. Again, these are the steps here in case I went too fast. Those are the steps. I can also do this without the graph, okay. I can also go back and go to the home screen. And again, alpha window has number 4 is the definite integral, 0 to 4. And then my integrand right here again is the square root of x. Get out of there, plus 1 dx. And again, a similar answer right there. And then using the Nspire, okay, use the Nspire. Notice the Nspire is has a little bit better closer to the answer. And I actually said, go ahead and approximate that to a fraction and got the exact answer of 28/3. Again, this is the Nspire non-CAS, okay, a little bit more powerful than the 84 version was. Find the area under a curve bounded by x-axis, the sine of x, okay. I thought I would illustrate that. I love going from 0 to pi, and you get that exact answer of 2, which just, with all those irrational numbers, just kind of blows me away there, okay. You can also just do it without the graph and just do the function integral there on the 84. Find the area bounded by 2 curves, okay. If we did this on the 84, I would graph it like this. And then I'll go ahead and say I want to find the area, and then I'll find the intersection points. Okay, so I found the intersection point. In fact, let me just show this one. Okay, I think that would be one to show live here. So back to y equals. So my 6 minus 1/2 x squared. And then 1/2 x minus 1. I'm sorry, minus 2. And I'll go ahead and graph those. And I need to find the points of intersection here. So on this calculator, second trace, number 5 is the intersect. And when you do the intersect, you have to say, well, what's the first curve? Enter. The second curve, enter. And since there are 2 points, I want the one, first of all, closer to, let's say, -5. So I'll say I want the one close to -5. And there's that x value. And I don't want to write that down. So I'm going to go off to the home screen. and I'm going to say, here's the value of x, only the many more significant digits. And I'm going to store that into some variable, this case a, so I can remember it, okay? And I don't have to write it down, okay? And I'm going to go back to the graph, again, find the points of intersection, which is number 5. And this time, first curve, yes, second curve, but I want the one closer to 4. So I'll type and say, I want the one closer to 4, and there it is, right there. And I'm going to go off to the home screen again, and now this value of x is changed, and I'll store that into, I'm sure you guessed it, alpha b, the letter b. Whoops. Alpha b, sorry about that. And now I can go ahead and use the function integration command and go from alpha a, whoops, and to alpha b of, and what I'm going to do, I don't have to type all that stuff, so I'm just going to say y1 minus y2. And then I love the fact that they make us put in the dx, the differential there. And there's my answer right there. I also did this on Nspire. I did it on Nspire. Nspire has actually a tool that says bounded area, and you just tell them what are the, you just pick the from upper bound to lower bound to upper bound. And so that works pretty well there. So I love the Nspire solution, and this is the non-CAS version, okay? And the answer was 43.7. It rounded nearest tenth. I could get it to more significant digits if I needed it. All right, so TI-Nspire has many interactive activities that are available for free at Math-Inspired. I'm just going to show you real quickly what they are so that you're aware of them, okay? So dynamic slopes of tangent lines. You can actually, using sliders, move a tangent line along a curve and find the slope of the tangent line, which, you know, of course, is the derivative, okay? Again, a different curve right here, again, showing the slope going from negative to 0 to positive, you know, to negative again, okay? Getting classic box problem, you know, if you notch out equal size squares, you know, what is the maximum volume and of that box? And you can actually collect data and plot it and then go ahead and find that and come up with a curve that models that. I love this one when we start talking about rectangular approximation method, midpoint, right, and trapezoid. This will do it for you and have a slider so you can have as many rectangles or as few as you want. I think it's a great visualization for Riemann sums. And just a few more things, limits, some ideas on limits, how you can approach limits, and there's actually an activity that does that for you. Vertical asymptotes, important to see those. We talk about those a lot. So this is the website, okay? When you go there, and I'll show this at the end, click on Calculus at Math-Inspired. It has all these units here, and each unit has a whole bunch of ideas that you can go to. So real quickly, we've got sigma notation on the 84, numerical derivative, numerical integral, and now logs to different bases, okay, is also available on the 84. So be aware of that. Okay, be aware of that. I love showing this, how you can show the properties of logs. If you add 2 logs, you're actually multiplying the arguments there. All right, so linear algebra matrices, I'm not going to show a whole lot on that, but I do want to show you what's available, okay, and why I like using them. So I'd like you to ask this question to yourself if you're talking about linear algebra and doing row reduced echelon form by hand. What's more important that your students can do? Multiply 2 matrices together, or be able to set up a problem, words to symbols, use technology to multiply the matrices, and then interpret what the product means and answer applied questions. So of course, I'm in the second one here, okay? Because here, if I ask my students to multiply these 2 matrices, and I want them to be able to do it by hand, but I don't want to overkill it either, okay? So again, this would be how I would show this using different colors and so on. And it is kind of tedious, but I do want them to understand row by column and so on, okay? But doing it on a calculator, you just go ahead and create the matrices and then say multiply those two matrices, A and B, and notice we're getting the same results, okay? Now, again, they have to show me they can do it by hand before I can let them do that with a calculator, and that gives them some incentive to want to be able to do it, by the way. So here would be a sample problem here, okay? A company with manufacturing plants in California, Texas has labor, hour, and wage requirements for the following, okay? What is the labor cost for one model B calculator in California? Interpret the product of these two matrices and interpret what each entry means, okay? So instead of doing it by hand, they can go ahead and set this up and then explain what those things mean. And so the labor cost for producing one model B calculator in California is going to be this entry right here, okay? Because that's where the California is, okay? The model B and the California is this row and this column, okay? And then this is what interprets what all of them mean, what all those values mean. And again, to me, the interpretation is very important. Being able to multiply is as well. What's more important is for the students to do elementary row operations by hand, do row reduce echelon by hand, or again, take an applied problem, translate it, explain what the solution means, and so on. So again, I'm of the second one. My son Matt, who's a civil engineer, rebuilding beaches, he would tell me when he would do problems, he would have to set up the equations, okay, take the data, set up equations. They had Excel, other types of things that would solve it for him. That was the least of his problems. But his thing was interpreting the results to the people he was working with. When he rebuilt beaches, he had everybody from his boss, who had a master's degree in engineering, to the guy who was dredging it, who maybe didn't graduate from middle school. And he had explained how do you slope those sands so that the beach is the way we want it, and so on. So again, the least of what he does is what we unfortunately spend the most time doing. Solving a 3x3 system, I think students should be able to do that by hand, okay? But using, and they can show me their elementary row operations. I'm thrilled that they can do that. But eventually what I want them to be able to do is to be able to take a word problem and be able to set up the system, solve it, and interpret it like we would do here, okay? Given this problem, set up the equations, and then go ahead and let the calculator do the work, okay? And interpret what do the solutions mean. So these are the 84 matrix operations that they can do. Notice there's a lot of them there that we do, okay? Determinants, transpose, row reduced echelon form, and then these are the elementary row operations down here. The Nspire has a lot more in it, okay, including calculating eigenvalues and eigenvectors, okay, especially for linear algebra. So again, before I stop here, if there are any questions, please, anything pop up before I turn this over to Lee?
Tom, at this point, the only chat that I got said, I like your focus on interpreting solutions, but I didn't see any questions.
Thank you, a virtual Pez for that person. Thank you. So at the very end, I'll need the last 2 minutes at the very end just to show the website where all the good stuff is. And so Lee, take it away. Oh, I need to stop sharing. Sorry about that. And Lee, I just gave you the ball. Lee, I think you're muted.
I unmuted you, Lee. You're good now.
Okay, thank you. I'm used to Zoom, not WebEx, and I don't know where the controls are. Thank you. Real quick, you can look and see who I am. I went from teaching high school classes of 30 to 35 students and having essentially an entire year to cover the statistics content, to now teaching it to 200 to 220 students and having 11 weeks to cover the same amount of content. And so if I wasn't into technology before, I certainly would be now. So yeah. Why use graphing calculators and intro stats? And I found this on the College of New Jersey's website, and they said they want to remove the technical barriers to learning as much as possible. Calculators will be used throughout the course for homework and exams, because while manual computations can be useful when you're learning a new concept, if all you're doing is extensive computations to arrive at an answer, you're really not gaining anything. So once a student has a feel for a concept, I want them to be able to perform the computations using either computer software or, in most cases, a graphing calculator, since they certainly can't use their computer software on an exam. I'm much more interested, as Tom said, in them understanding the concepts, applying the concepts, and interpreting the results. This is not a crank out algebra class. Okay, so I'm going to show you some of the things that the TI-Nspire and the Nspire will do in statistics. Specifically looking at graphing calculators for EDA, exploratory data analysis. With univariate data, they can do graphs and one variable statistics, histograms, box plots. The Nspire will even do a very nice little dot plot for you. Of course, your mean, standard deviation, 5-number summary, those types of things. With bivariate data, they'll do graphs and all of your regression, scatter plots, residual plots, your regression equation, correlation coefficient R, and I left off coefficient of determination R² as well. So this is the type of thing when I'm teaching my students that I actually put up. These are the kind of directions I put up. And when I'm actually teaching my classes at UCI, I am running both emulators at the same time, because what I have found is that most of my students actually already have a graphing calculator when they come to class. They already have a graphing calculator from high school. In most cases, it's a TI-84. I do have some students that have Nspire. The few students that don't have calculators, I suggest if they're going to buy one, they buy an Nspire, but they could buy, I will take either one of them, and I actually teach with both of them at the same time and have both emulators up running at the exact same time. So I'm not going to take the time to go through all the, all this loading data into you. With my students, I will tell you, I actually do go through all the steps with them so that they can actually be following along. For the sake of time, I'm not going to do that here. I'm going to just, I have the data already installed. For instance, here's my 84. I went into stat, edit, and I've already put in all the lists that we're going to be using today. We're going to be using this first one. This is text message sent by students in a day. If I want them to graph it, they're simply going to go to second, stat plot, make sure that plot is turned on. We're going to use plot 1. And then what kind of a graph do I want them to do? Well, let's do a histogram first. And let's use list 1. And then they're going to go down and graph it. I have to go to zoom 9 on this calculator to graph it. And there we go. Very, stripped down, but your basic graph. On the Nspire does the same thing. Here's that same data. On this one, I would go to, I need to add another page. And I'm going to add a data and statistics page. And then I'm going to put in my variable text. The first thing it does is give me that dot plot, and then I can choose a different type of plot. For instance, I can choose to make it a histogram. On both of them, I can go in. Notice that the bin sizes are different between the two. I can go in and adjust those as I need or as I want. Okay. Now, what about, and by the way, this is the kind of thing when I'm doing this with my students, I give them the step-by-step directions just like this. I also give them all the screenshots so they can see what they should be following along. And that's in the lecture notes that I provide for them. Okay, let's look at box plots. What do they show or not show? Box plots are great for outliers, center and spread, comparison of multiple data sets. They're not so good for shape. Okay, so let's look at box plots. We can do them by hand, and I do show them how to do them by hand. If they're doing them by hand, first they have to find their 5-number summary. Then they have to find their IQR, subtracting Q3 minus Q1. Then they have to multiply that by 1.5, and then they can get their thresholds, and then they have to determine which of the values are in fact outliers. Okay, on the graphing calculators, it's a little bit simpler. I'm going to start on the Nspire since it's up on top. I'm going to add another page, and I'm going to simply do it again. Except this time when I change it, instead of changing it to a histogram, I will change it to a box plot. And there we go. Nice, and you can trace it literally just by holding your cursor over. You see your minimum value. That's the last value, not a threshold. Your Q1, median, Q3. And then here are your two outliers. There we go. The 84 will also do that. I'm going to go to my stat plot. When I come in here, you want to make sure you select the correct one. The 84 is actually set up this over here that looks like also a box plot. That's for middle school kids, if where it doesn't check any outliers, and we do expect our kids to find outliers. Make sure you select that and then come down and do a zoom 9 again, and there's your box plot. So you get the same graph. It's just not quite as pretty on the 84. Now, and again, I show them that. What's the difference between a box plot and a histogram? So this is graph time in minute, and I'm going to go to a new set of data over here. I'm going to do a 5-number summary of each of those, and I'm going to look at the box plot on the next page. So I'm going to actually do a box plot for this one. So let's do a box plot. There we go. Give you a little hint there. Box plot doesn't show much of anything. But the problem with that box plot, as you saw when I was creating it, is, let's do a real quick page layout. Let's put a second graph on here. And let's do that dot plot. While a box plot is great for showing outliers, it does not show shape. And so you want to make sure you show students something like this so they can clearly see the difference between them. Okay, we can do our basic data analysis with each of these by going back to, let's go back over here. I'm going to come here, I'm going to go menu, statistics, calculations. Here's my one variable statistics. I'm going to do it on texts. And there's your standard one variable statistics, mean, sum of x squared. There's your two different standard deviations, your sample and your population. And then underneath that, you get your 5-number summary. Doing the same thing on an 84. I would go to, let's get out of this and go to stat, calc, one variable statistics. The terminology is the same. It's just hiding in different menus. So I want to do this one to be list 1 again. And then I calculate it and it shows up right here. Okay, same values as you would expect. All right. And again, for my students, I show them how to do it in class. I give them the steps. I also give them all the screenshots. And like Tom said, you will have access to both of our PowerPoints as PDF files so you can see what we've done and go over them yourself. Bivariate data works essentially the same way. I want to show the Nspire because it's got a really nifty little tool on the Nspire. So I'm going to come over here. Okay, here's a set of data. I'm going to go to and add that graphing page again. So here's my first variable, femur. I can add the second variable, humerus here. Nice thing is I can come in very quickly into my analyze and add. I can show the line, boom, but it's got a really cool feature that my students really like. When I push them, I want to say, well, what about your residual plot? It will actually show the residual plot right on that same page. So the students really get an idea of what a residual plot is, that we just took our line and flattened it and then sort of spread it out to fill in the gaps. So we can really see any exaggerations in the shape that might exist. Okay. Okay, and then again, there's things. Another thing, what I want my students to know about bivariate data is I want them to be able to read a scatter plot, which means I want them to look for the linear trend or not. So I want them to be able to quickly see a graph. I want to be able to talk about whether it's a positive or negative association, the strength of relationship, and any outliers. And the graphs help me do that. I can get my regression equations also very simply on here, and I can use them to predict y or estimate y, and then interpret my slope and y-intercept. Okay, Tom mentioned the really great activities. I want to do the same kind of thing that he did. It suggests that you go to that. There's some great activities there. I have a couple of real favorites. Influencing regression is really a cool one, as well as my central limit theorem. And I'm going to quickly show you the central limit theorem. And the cool thing, as Tom said, is just by showing up today and giving us an hour of your time, you're going to get both of these softwares, or so you can actually show them with your students. The central limit theorem one is, to me, just absolutely amazing. We start with a uniform distribution, and then we can just keep a sample size of 1. Essentially, we get almost a uniform distribution. But as soon as we go to a sample size of 2, it starts mounding up. And by the time we get to 30, we've essentially got almost a normal distribution. And here, if we start with a normal distribution, our sample size, 200 samples of size 1 is going to be normal, so it's just going to get skinnier. When I start with a skewed distribution, sample size of 1, it's still skewed. When I go to sample size of 2 and on, it starts getting approximately normal very, very quickly. And then the last thing what this actually does is really cool. It actually shows the same thing. But what if you have a binomial? What's the probability of getting a 2 when you roll a die? Either a 1 chance out of 6 versus 5 chances out of 6 that you don't get a 2. And so you notice that even this one starts to mound up into your approximately normal distribution by the central limit theorem. So and again, you can run this as a demonstration. While it's great if the kids can see it themselves or do it themselves, having it as a demonstration is pretty amazing. I'm not going to take the time to show the permutations and combinations or the binomial distributions, because Tom did some of that last week, but just know that binomial PDF and binomial CDF are, as well as your normal distributions, are there, and they're really kind of amazing for students. Let's get down hypothesis testing. Over a third of my course is hypothesis testing. So what's important in hypothesis testing? I want my students to know how to write null and alternative hypotheses. I want them to be able to select which test to use and check the conditions necessary to use it. I want them to find an appropriate test statistic and p-value and make the correct decision and interpret the decision in context. That's what I want them to know when I'm done with inference. Now, steps 1, 2, and 4, they have to do it no matter what. The only thing that changes with graphing calculator technology is how they find the test statistic and p-value. Okay, so if I have a problem like this, random poll of 355 people shows that 54.1% of them plan to vote in favor of measure. Can we conclude it will pass? They have to define the parameter, come up with their hypotheses. They have to name the test they're going to use. It's a 1 proportion z test. They have to check their requirements, told they have a random sample and it's large enough, and then they can crank out this lovely formula and get the p-value from a table. Or they can do the exact same thing and get get it from a graphing calculator. So I would do something like this. I would go to, let's clear this. Let's go to stat. I come over to tests. I want them to do a 1 proportion z test. Okay, the hypothesis that we're testing is 0.5. My x, I wasn't given data this time. I'm given, so I want to go 0.541 times, what was the population, what was the sample size? 355. And then I have 355 And I'm testing greater than, right? And then I calculate. Wait a second, I got an error message. What happened? Well, if I go back in here, let's quit. Oops, think about it. X has to be an integer value. X is a count of successes. So I would have to change that to my 192. And now if I run it, it will give me the test statistic Z and the p-value that I need. And I can then go ahead and draw my conclusion and put it in context, which is what I want my students to be able to do. I don't care if they can do the algebra. I'm not teaching algebra, I'm teaching statistics. Okay, and this is all the different hypothesis tests that are available on the 84 and on the Nspire. The Nspire, Tom talked a lot about the CAS. CAS on an Nspire really doesn't make any difference in statistics. It works just the same as doing as the CX model. So your students don't need to spend the extra money. With confidence intervals, the same kind of thing. I want them to know how to select which interval to use, to be able to check the conditions, find the interval, and interpret it in context. They're still going to do steps 1 and 3 totally on their own. The only thing that's different is here's my new problem. We've got this time we're told that 59% of a sample we want a confident out of a poll believe that the world is going to end. I love the things we get to talk about in statistics and as far as our examples. This time I'm going to do a confidence interval for it and interpret it. It's going to be a 1 proportion Z interval. My conditions, again, my sample has to be representative and large enough. If I'm doing it by hand, I would do all this kind of crazy cranking out, but I don't have to do it by hand. I can do it by using my graphing calculator. This time I will use the Nspire. So let's come over here to a new page on the Nspire. So I will go menu, statistics. I'm going to do the confidence intervals. I'm doing a 1 proportion Z interval. I learned last time that I can't put in a decimal, so I already figured out ahead of time that that's 592 out of my 1003. I'm doing a 95% confidence interval, and there we go. We got my lower bound, upper bound. There's my actual proportion, which is 59 and a decimal. And there's my margin of error, as well as my count. So, okay. And then they'd have to put the conclusion. I'm 95% confident that between 56% and 62% of American adults believe that the world will come to an end. Kind of a scary thought, huh? These are the confidence intervals that are available on our both the 84 and the Nspire. And then lastly, some quick references. Years ago, TI put out a statistics handbook for the 83 graphing calculator. Well, the 83 and the 84 are almost identical as far as their functionality, at least in statistics. So the 59 topics that are covered in that work just as well for today's 84. And there's a so you might want to look for that. There's a similar one that was put out actually by the Hong Kong International School. That's TI-Nspire calculator skills for statistics. And then again, a link to that Math Inspired. And I think I've left us with 6 minutes, which was, I think, my target. So, all right, I need to unshare, stop sharing. And Tom, I think you're back on.
Okay, well, thank you. I learned a lot. Of course, I'm not the greatest statistician in the world. Do you need to pass me the ball? You have to physically do that? I'm not sure I can grab it.
I don't know. I am
under participants. There, I just got it.
You just did it, Tom.
All right, thank you.
There you are.
Thank you. Okay, so like I said, I learned a lot. Thank you, Lee. That was really good. A lot of stuff there. Now, you mentioned the Hong Kong International School. It's weird. I've been there. I actually taught them Nspire for a week. So I was there and worked with them. So that's kind of cool that they're using Nspire and have a nice handbook. So,
and they've actually put out the best handbook on using Inspire for statistics of anybody.
Wow.
So thank you.
Oh, wait, there's a question in the chat, it says. Let me see if there's a question in the chat. Can you add a movable line and see the residuals change in real time?
Oh, yeah. Oh, yeah, you certainly can. The statistics component of the Inspire was built by the same people who built Fathom. So it has a lot of Fathom-like properties. So where I went to the residual and showed the residual squares, you can do all of that. You can change the movable line, you can change the line and see it. You want me to quickly pull up? I've closed my Inspire. Yeah, it will do all of that. So it's a great demonstration.
Okay. Okay. So Christy, thank you for your question there. It says, and also in the residual squares, that was the second part.
It will do if you draw the line, you can put your own line on and you can see how R and R squared change, and then you can actually have it show the residual squares. And as you change the line, the residual squares change.
Okay, well, good. Thank you. And Christy, again, Pez for you for asking a good question. Thank you. Virtual Pez, that is. Okay. All right, so this is the website that I created for you, anybody there who came to the webinars. Veronica, Lee's, and my email addresses are there. If you were here last week, this was the information. If you weren't, you're welcome to get that information there as well. These are what we added today. So Lee's slides are already up there online. So those are mine.
Tom, can I add? I see another question in the chat that I would like to address.
Sure, go ahead. Sure.
And that was why I recommend the Inspire versus the 84 for statistics. If you look at the difference between them, it's pretty phenomenal. It's like the difference between an iPhone and an old Motorola flip phone. I mean, the graphs are much better quality. They come, when you do a graph on an Inspire, it's already labeled the horizontal and vertical axes. The graphs are to an appropriate scale. There's numbers on the axes. It's just the graphs are far superior. It also just plain does a better job of the statistics. When I did a confidence interval, you don't get as much information off the 84. You only get the upper and lower bound. You don't get the margin of error. You have to figure that out by hand. It just gives you a lot more information. It's really a very strong statistics machine. It's not quite like using computer software, but it's amazingly close, and it's also extremely easy to input data into. I mean, you can actually input data as opposed to having to type in data. So if students don't have a calculator, an Inspire is what I tell them to buy. If they have an 84, I'm not going to, for an 11-week class, suggest they go out and spend another $110, $120. But if they don't have a calculator, it's worth the extra maybe $10 that it costs for an Inspire over an 84 for statistics.
Okay, good question. Thank you for asking that. Whoever asked it, as for you as well. All right, so these are Lee's slides here. Okay, so you can see they're thorough, exactly what she showed you. So again, that link is right here for her slides. My slides are right here. Okay, showing what I talked about. So you can go back through and look at them, use them however you want. Other things that are on here. So there's tips and tricks on the 84. So that's the most common one. As Lee and I agree, we think Inspire is more powerful, but 84 is more popular. If you're interested in finding out how to do anything on the 84 tips and tricks, I have both a PDF first and then a video explaining it. So you're welcome to use that part. This is 84 Activity Central. We talked about Math Inspired. You can go there and look at statistics and see what things are all there in statistics. These are all units that have several different things, and maybe find Lee's favorite ones that she shared with you. We also have, here is the Math Inspired. Okay, so you go to like calculus and pick on derivatives. It'll take you to a website or a page that has a whole bunch of different ones there. Look at all these you can download. They're all free to you. And as Lee said, you have that software. You can play these all as demonstrations. Okay, there's directions for them, the whole deal. Transformation graphing, this is not part of this, but if you've got students that can't graph these functions in their transformations, TI has created a website that has over 250 videos. And if you just go there and just click on the quick reference guide, this will tell you exactly what is done, the examples that are done in the videos, the now you try ones, squaring function, and so on. Something you give your students, say, if you can't do this, here's a website that'll help you do the transformation graphing. TI's websites here, other things here. These are the two TI contacts and their email addresses, telephone numbers. And if you ever have problems with tech support, they are tremendous. They are tremendous. So,
Yes.
Parisa, what do I need to put up the PowerPoint
Yeah,
now?
if you could just put up the last couple slides, Tom, that'd be great. We're going to wrap up here in just 2 minutes, everybody. I appreciate you sticking around. So if you can go to the next slide, perfect. So one thing we wanted you to be aware of is our technology rewards program. So as a college professor, we have a separate technology rewards program for universities and colleges that you can redeem for different technology for your whole department. You can redeem for graphing calculators, software, PD, whatever you'd like. And that can be found on our website, education.ti.com. And then we also want you to know about our syllabus promotion. So we're going to send you software for the TI-84 Smart View and TI-Nspire Premium Teacher software. But if your whole department needs the software, one way that you can get it is through our syllabus promotion. So if you send us a few of the syllabi from your department that say something like, we use TI-84 in the classroom, we recommend if you're going to purchase, you purchase TI-84 plus CE. We'll give you perpetual licenses of that software for your department so that you can use it for modeling and instruction. And of course, all you need to do is reach out to your ETC, your education technology consultant, to be able to find out how to do that. Tom, if you can go to the next slide. So the link there to reach out to us, it's on our main website, education.ti.com. But if you type in /en/purchase/sales contact, you'll find us. We're also under the where to buy tab if you need to locate where we are. And go ahead, Tom. I think we always encourage you to follow us on social media across all the platforms, and we're TI Calculators is our handle at every platform there. So you'll see lots of updates and activities and resources that are available to you. Again, that is our website. We appreciate you guys being here. You'll get an email with the link to the recording in the next couple days and an email with your software in the next couple days. Thank you all so much for your time and for joining us today. Bye-bye.
And contact us anytime with questions.
Yep.
Tom, will you put your bit.ly for that website just in the chat, just in case anybody didn't grab it?
I did. I
Okay.
did do it.
Perfect.
And I have a quick question. I mentioned the